Oh, I was just an NCARB meeting in Washington about 3 weeks ago.
All right, good evening, everybody.
So it's a whole loop right in.
Thank you for coming. So welcome to the College of Architecture and Design at Lawrence Technological University. My name is Carl Dobman, and I'm the Dean of the College of Architecture and Design. So welcome to everybody that's joining us in person tonight, but we're also broadcasting live. So welcome to everybody that's joining us online, and welcome to everybody that's watching us in the future right now on YouTube. Our college is unique in a number of ways. So we offer degrees that range from that of the scale of an interactive game to that of the scale of urban design and the city. We're focused on design, we're grounded in practice, and we're immersed in technology. So given our strong ties to practice and our strong interests in technology, I was incredibly excited to be able to invite Rolando Mendoza to come speak with us this evening. This is where it gets, that's as far as I got in terms of our introduction. So I was touring Rolando around the school, and we were talking about all sorts of really exciting things. So Rolando has an amazing range of experience. So, and I guess I'll say Rolando and I have known one another for 20 years. We were grad students together at MIT. Before being at MIT, Rolando got his architecture degree from Florida A&M University, and then he did a Master's of Architecture and a Master's of Science in Design and Computation at MIT. After that, he was a project designer at Morphosis. After that, he was managing director of Gehry Technologies. After that, he was at Disney. He was Imagineer at Disney. And actually, that was the point, that was enough that I was like, we should invite Rolando to come talk with us. But then I thought he was still in Los Angeles, and I thought he was still working for Disney. But that Disney job, he's been all over the world. And so what he's going to talk about tonight is the range of experience of being an architect, but where that's taken him in the relationship of technology, how that's evolved. But Rolando, from being an Imagineer at Disney and dealing with construction, and you were in China, building huge projects for Disney in China, and then now finding out that he's moved to the Midwest, and he's in Minnesota, and he's the director of VDC for Mortensen. And so VDC is, I think what we're saying, the new term for BIM. So BIM, for those of you that are just catching up to BIM, BIM is already old and out, VDC is in. So VDC is virtual design and construction. And so Rolando is going to pose the challenge to us in terms of the fact that construction, and maybe what we do as designers as we think about buildings, as architects, that there's disruption on the horizon. And so Rolando is now being tasked with a global construction company to think about what is the disruption that's coming within construction, and how do we prepare for that, and how do we think about that? So I think he's going to challenge us on some of those things, and I'm looking forward to a really great talk tonight. So let's welcome Rolando.
Has anybody heard the term VDC before? Show of hands, just 1, 2. So VDC, it's really simple. It's virtual design and construction. And the way that I like to explain it is you build the building once virtually so that you build it right physically. And so you work out all the kinks through that process and make sure that everything is to the level of detail that it should be for construction. BIM is still important because BIM is the foundation of VDC. Without the model, you don't have VDC. So I just want to make sure that that's clear. So BIM is still, I know, it's still relevant and it's important. So the title of my talk is How to Build the Impossible. And what I thought would be good, given this audience and given that I haven't talked to a group of students at a School of Architecture in a long time, most of my talks are at professional conferences with big construction companies that are fully aware of all of these tools and these processes. I really wanted to walk you guys through a journey, if you will, and it's kind of a journey that you guys are going to be starting out yourselves in your own careers. So this idea of the impossible for me really starts with these two images. On the left is Gaudí's hanging chain model. The fascinating thing about that is Gaudí had an idea in his head. He had a vision, but he didn't quite understand how to describe that vision or how to communicate it. If you were to approach it from a traditional architectural standpoint, you would think, well, I'll draw some plans and some sections, some renderings or drawings by hand. But the vision that he had didn't really align itself with those methods. So he had to invent something. And that's the ingenuity of design and creativity and architecture, is that you've got an idea, you've got to invent the way and the process to document and communicate that idea. The same holds true for Felix Candela in his hyperbolic structures. The beauty of that form there is the method of construction that goes into that process. All of the ruling lines that define the geometry are actually the lines that are actually constructing the building. Very powerful stuff, the idea of a vision and how to begin to communicate that vision. So for me, early on in my career, as a young architect, I started out drafting by hand, ink on Mylar. At the end of an 8-hour to 12-hour day, your fingers would be covered with ink. Sometimes that ink would stay for weeks. That's how people knew you were an architect. You'd go out, and meet people, socially, and they'd look at your hands and they'd realize, oh, you're an architect. But the interesting thing about that was the pace of the work. It was slow. It was deliberate. We took time to cut the contour lines of that model. We took time to draw the plan, to build, the adjacencies and the program, and to really visualize this in a way that today, with the tools and the technologies that we have, it's fairly easy. So I want you guys to think about, as I'm talking and presenting, what are the things that we're losing from this process as we gain technological prowess. So a lot of physical models. This model was actually, in a lot of ways, our BIM back then. It was actually used in the field for construction. So the tradesmen had to verify the measurements on this physical model. And this model was pretty huge. I mean, it was about, twice the size of this table. But the project gets built, and that's always the exciting thing, is that moment of actualizing, the design into reality. And that's really the driver for me in my career, has been, idea to hand to form to building. And in doing so, we had to come up with ways to represent these geometries. And so here's a really simple example of this staircase where we had to do multiple cut lines to be able to define the dimensions of this design. As a young architect, you could imagine, as you're sitting there drawing these things for hours, you're thinking, God, there's got to be a better way. And so that was the impetus for me to start thinking about new ways of working and new ways of designing and using tools in a more direct way. And so that's what brought me to MIT, where the theme really was about new tools. And I remember Carl walking in at 2 o'clock in the morning one day in the computer lab and asking me, hey, what toy are you working with today? I was always looking for the next tool to test out, to use, and it was interesting. But it was really about this idea of form and how do we begin to think about form in different ways. So on the left is the work of Thomas Wentworth, no, Wentworth Thomas? Darcy Thompson, yes. Sorry about that. And on the right is Frey Otto's soap bubble experiments. And so the idea here is figuring out new ways and new methods to come up with form. And so I was introduced to the computer in a different way and began to look at, you know, simple things like how do you take a sphere and morph it into a different shape? And what does that imply in the design process? Began to look at Maya, Rhino, all these different tools that were starting to come into the market that began to imply a different way that we can begin to look at architecture. That then took me, for my first professional job as an architect, to work in an office implementing some of these strategies. The first project that I worked on when I joined Morphosis was the San Francisco Federal Building. It was a design competition that Morphosis was awarded. And the whole process of this project was really about the facade and the veil that covered the building. It was a building that was also going to be responsive to the environment. So it had operable windows that tied to the National Organization of Atmospheric Administration that tracked the weather nationally and communicated back to the building. And so the building was constantly moving and responding to the weather conditions. So my job was really to look at that facade in a more integrated and systematic way. And how do we begin to document this for fabrication purposes? And so, you know, coming up with simple ideas of how to use the computer to very simply generate a strategy or a method that we could then use to model 569 varying panels with different folds at different conditions. And then putting that into a production process in the computer so that we can then generate the documentation for it. So here's some examples of the model as it was for construction purposes. And the beauty here was that we then were able to integrate multiple trades into one model so that they can work more seamlessly. The facade itself had 3 different layers with 3 different vendors or trades that had 3 different contracts. And so that created a communication challenge because those 3 components had to be working together, not just geometrically, but also contractually and for construction purposes. The next project that we then further developed some of these ideas was the Eugene Federal Courthouse, where now the idea was about a ribbon that wrapped around the building. And so this ribbon sort of encompassed a number of courtrooms. And so what the intent was that as these things peeled off and folded, it needed to seem as a seamless flow of metal. And so again, how do we begin to document this information and really begin to integrate a lot of these ideas through the computer? We began working with Robert Aish, who was a researcher at Bentley at the time. We were using Bentley Triforma, which is a modeling tool, not very similar to Revit and CATIA. But one of the things that was exciting was that Robert Aish was starting to develop a visual programming tool called Generative Components. It's the precursor of Dynamo. I don't know if you guys know about Dynamo or have used Dynamo in Revit, but Robert Aish basically invented the whole idea of visual programming for architecture. And so we started to use that, and it was really interesting to see the relationship between the image on the right, the little bubbles, which is the narrative, and then on the left, the geometry. So now you've got this direct correlation between the script and the program and the responsiveness of the form. And then obviously bringing that all together again into this master model process of integration. That notion of integration, you're gonna hear me say that a lot in this talk. It's a very important component in terms of how all of the different disciplines and pieces come together. So here's some images of the finished product. I mean, it's a beautiful building, and that's ultimately the goal, regardless of whether you're using a purple crayon or the most advanced modeling software. That then led me to Gehry Technologies. While at MIT, Frank Gehry was commissioned to build the Stata Center, which is the computer science, the School of Computer Science at MIT. And while he was there, he and his partner, Jim Glimpf, conducted a number of studios and workshops. And I was able to work with them on some of those studios and got to know them, got to know Jim Glimpf really well. And so my goal at that point was I want to go and work with Jim Glimpf. I mean, he was at the time, I think, the only architect that was talking about technology in a completely different way. And so it was really exciting when I got the news while I was at Morphosis. And it was interesting because Morphosis and Gehry's office were literally just around the corner in Santa Monica, Cloverfield in Colorado. So lunchtime was hilarious because we'd all meet at the corner of Colorado and Cloverfield, and you know, the Gehry guys and the Morphosis guys, we'd all go to lunch, and we were all friends and talked to each other. But I always kept in touch with Jim and keeping my tabs on what they were doing. So it was exciting to hear them peeling off this whole new group within the Gehry Partners organization that was going to be completely focused on the development of tools and advancement of technology and architecture. And so when they approached me to join them, I said absolutely, and from there was really the next phase of my career, if you will, where I learned a lot about the relationship of construction and design. And so at Gehry Technologies, the process was really very simple. I mean, it's an idea. How do you take a sketch, a gesture from an idea like this from Frank, and begin to then develop a whole process of design that is leading you towards the resolution of the project. And what people don't understand about Gehry is that he's very, very disciplined in terms of how he works through his design process. People think, the form comes first. Actually not. It was actually the program blocks that began to sort of form the body of the building. And until that was dialed in, that Frank then began to do the gestural moves on the skin. But this was a very important piece of the process. Lots of iteration, lots of physical models. And then eventually, to the final design model, the master model, if you will, that would then become the template for the basis of production. And so here you have, the digitizing arm collecting all these points to begin to document that design so that we could then take that into CATIA so that we can then start to develop all the detailing and the engineering for the construction. It's very simple. It's, it's going from sketch to, to a computer model in a very rigorous way. And we learned how to do that in Frank's projects very effectively. And as we saw, the Disney concert hall as the the little cousin of Bilbao in a lot of ways, because a lot of the ideas that were generated for this project came from that. So Gehry Technologies, it was an interesting group of people, architects, computer programmers. We put together a very diverse group of multidisciplinary, creative technologists, scientists, programmers, engineers, and I believe that it became the first, or the model, if you will, for the BIM service business. After Gehry Technologies, a lot of companies began to do the same thing. One in particular, one group out of New York called CASE, was probably one of the most successful groups that grew out of that, and just recently got bought out by WeWorks. So now WeWorks has an internal group that is literally, driving the delivery and the design and the integration of their projects, which I think is pretty brilliant. But the whole focus of Gehry Technologies was, now that we've done this on Gehry projects, how can we begin to provide this service to others? And so we went out to the world and we did this, and we began to provide services to the younger architects that were up and coming, the Zaha Hadids, the Herzog and Demirons, the Hani Rashids, who had ideas and had visions, but didn't have the methods or the processes yet to be able to execute that. And so that was an exciting moment in my career, where we can begin to share this knowledge across the industry. And one of the mantras that we had, and it was actually Frank who came up with it, was, his whole drive in doing this was to transform the industry. He wanted to give power back to the architect, give control to the architect. He always said that he or she who owns the information has the power. And that holds true today. I think that is a really important thing to keep in mind as you think about technology. So here's a project that I would say is, in my opinion, probably the pinnacle of this whole integration of building information modeling, computational design, where a lot of these ideas culminated in a very beautiful and productive and effective way. This is the Louis Vuitton Museum in Paris. It's set in one of the most beautiful parks in the center of the city. A lot of sails, a lot of forms that you would typically see in a Gehry project. Very organic, and here's some images of the construction. But the thing that I really wanted to focus on was really more about the process and how we were able to combine the parametric modeling that we were doing with new ideas of collaboration and new tools, and really coming up with a structured way for collaboration. Nobody had done this before. There wasn't a Navisworks or a BIM 360 or anything like that at the time. And so we literally had to begin to think about really simple things like interoperability. Everybody's using different tools. Everybody's using their own methods. How do we begin to bring these things together in a very effective way? How do we begin to think about all the different scopes of work as different components that need to come together in a way that brings all of this information into one single source of truth, being the information in the model. And so what you see here is us basically attributing that information in a way that we could then effectively schedule from it, estimate from it, and integrate from it. And so we had to create literally an intranet, if you will, of the project, because we had consultants throughout the whole world that were working at different time zones and at different geographic locations. And so we developed our own model server where the information that was centralized was constantly being updated. So everyone had concurrent real-time data of the project. And then we created a sort of tiered access to that information depending on your role and your persona. And then, again, how do we then interchange this information and exchange it with everyone? And so we had to come up with a method of doing that. And so we were inventing literally a way to collaborate through the model. Data aggregation, data distribution, how do we then leverage this for other functions like visitors, security? There's a lot of information that's being captured and knowledge. The important thing was then how to democratize that and share it with others. Maintenance database as well. So this model now really becomes more than just a representation of the design. It actually becomes a center of information and data that can be used for other things. So I'm going to kind of go quickly through this. Are you guys okay? Everybody with me so far? Not getting sleepy? I know it's late in the day. Part of this too then is the training. You have to train people. I mean, nobody knew how to do this. And so not only did we have to execute and implement, we actually had to introduce a whole project team on a whole new way of working, new tools, new processes, and constantly updating the guidelines and the standards so that everyone kept focused and on track. And then the final product, as you see it coming together, I always love these pictures of the construction. And then generating a lot of intelligence in the componentry and in the development of the design. These are very unique conditions that varied from joint to joint. Capturing that knowledge in a parametric model and then being able to deploy that effectively and then rationalizing that for fabrication. So going straight from digital to the factory. And then optimizing the material. One of the challenges that we had was how to make a complex curved building economical. And so what we had to devise was a way to generate these curves from a single curved surface, meaning conical. So if you can just bend glass in one direction, it's much cost effective than if you bend it in multiple directions. And so we had to devise a way to be able to control the geometry with computation so that we can then generate the illusion of multiple curvature, but only with one single curve. And so what you're seeing here is that process where we're taking the computer and optimizing that process so that we can generate. And then we could actually test to see through some rules which panels aren't meeting the criteria. And that's what you're seeing here. And so we ran this iteration multiple times so that the red would go away. And if the red didn't go away, but it was just one panel, then we could live with that. That wouldn't be the end of the world. But it was a matter of reducing that process. And so here's a sort of diagram of that workflow where you're going with the geometry all the way through the parametric definition and then the documentation. Here's another project that we then took all this knowledge to somewhere else where you would think, well, there's no way that you can capture this level of sophistication. So this is Mexico City. This is a museum where we were hired by the architect, Fernando Romero, from Free Design, to panelize this facade with a hexagon. The challenge that he had was that he had locked the shape because he had to buy the steel early. And so now he's got this shape that we can't change, and we have to then panelize it with a hexagon. And initially the idea was it's got to be one hexagon pattern, which is impossible on an irrational shape. And so part of the process was to kind of educate the team on the complexity of the geometry. So we showed, how you unfold a soccer ball and a lot of exercises, academic exercises to kind of show what the complexity that was created here and what the challenge was. And so we had to write a script literally that constrained the gap to a certain dimension within tolerance of 3 inches, and then optimize the number of families or groups that we can come up with. So that way, if we could reduce 14 variations of this panel versus 2,300, it would be, I knew this was going to happen. Yeah. Sorry about that. There we go. My apple. So where was I? I'm sorry. The variations down. So we were able to control that and optimize that. So this leads me into the world of Imagineering and coming on board as the executive of project integration. And really, my whole focus and effort there was about delivering the largest public-private venture in the history of China, between the Chinese government and a multinational company, as well as the largest project in the history of the Walt Disney Company, estimated at the time at over $5 billion. And so when we started thinking about the project, I told them, there's absolutely no way we can go to China and not use these technologies. You guys are watching that, aren't you? It'd be impossible to think that something like this would not leverage these tools. And so we were able to convince a lot of the executives that there was no way we could not do this. And the concern was a viable one. It was a market that nobody knew. We didn't know the capabilities of the Chinese contractors, the local design institutes. We knew that they had some experience on projects like the Shanghai Center, which is the twisting tower designed by Gensler. So they were starting to get exposed to new ways of working, as well as the Beijing National Stadium for the Olympics. So I argued that there was hope, that there's something there that we can do that we could leverage. This also in the face that China, and I think it's true to this day, is going through tremendous amount of growth. And this data point was really interesting, and it's quite dated, but I think it's still relevant. China in 3 years actually used more cement than we did in 100 years. I mean, think about that. That's just mind-boggling. And so if you think about that in relationship to productivity in this industry, we start to look at what the challenges are on a project this big. And so the red line shows historically where this construction industry has been for a long time. And then all non-farming industries like finance, automotive, aerospace, even agriculture have seen tremendous productivity efficiencies as a result of the digitization of those industries. So to put us into context a little bit, this was Shanghai in 1983. This is Shanghai today. Most cities in America wouldn't, I mean, we don't grow that fast. This is literally a city that grew in less than 20 years with skyscrapers the size of New York. And also compounded with ourselves. I mean, we were a very complex organization. A Disney project had over 140 disciplines that needed to come together to build the project. It wasn't just the facility guys or the MEP guys or the guys that we think about in a traditional construction project. It's show designers, theme, animatronics, ride engineers. The list goes on and on and on. And it was like herding cats. And the way that I used to describe it was it's like a rugby match where everyone is on their own team and they think they have the right to the ball. And so that was part of the challenge as well. So we had to come up with a way of bringing this all together. And so what I came up with was this idea of project integration, where we took the best of technology and tools and coupled that with people and created this notion of a collaboration space that was really focused on three things, which is the 3Ds, what I called. Decide, document, and deliver. And we did that through a series of activities. We used a lot of visualization, virtual reality, cave, immersed not just the creative groups into these spaces, but also our trade partners and our contractors, so that they can start making an emotional connection to the project, what it is that they were building. We linked our schedules to the models, so we did a lot of visual planning with 4D, and then implemented in the field. How do we take that information and then begin to communicate it more directly out in the field using total workstations, robotics, iPads, and then verifying, being able to verify that everything was being built according to plan, and that we did through laser scanning. And so this was the iterative cycle, the day-to-day grind, if you will, of bringing all of these pieces together into the stakeholders. And the stakeholders had to come in and make decisions and tie their decisions to the model, to the schedule, to the estimate. This is not a new idea. We got this actually from Stanford, the Center of Integrated Facility Engineering, who actually got it from JPL in Pasadena, NASA. Basically, NASA, this is how they launch their missions. They bring everybody together into a room, and they're constantly working and talking with each other, communicating, making sure that everyone's in tune with every decision that everyone is making. There's a great book out just recently by a general, I forget his name, called Team of Teams. Highly recommend it. I think it's really relevant to a lot of the stuff that we're facing in construction as well as in other industries. And then using BIM and technology and the tools to bring all the different multidisciplinary stakeholders into one single source of truth and mapping that out into this roadmap. So from that project, we were able to then develop the roadmap that we were then going to use and implement for Walt Disney Imagineering. And we taught the Chinese market, we taught our own people, our Imagineers. One of my initiatives was to try to get the regulatory agencies in Shanghai to understand the value of what all of this meant. And so, and we were able to do that. They put a program, a plan, a 5 to 10 year plan where the tourist zone where Disney sat, all projects from 2013 on that were above a certain price were going to be required to have a BIM submittal for regulatory submissions. And so we educated the municipalities. We took them to Singapore to meet the Singapore government, who had been doing this for years. They've been doing e-submissions and BIM submissions in their building departments way before anybody has even thought about this. And the reason they do it is because it's by necessity. Land is limited in Singapore, and so they have a very rigorous process to make sure that their planning is done effectively. And so yeah, so mapping out the whole BIM process where, you know, we start to organize how we organize the information, get away from a paper-based process and start thinking about this sort of multidisciplinary 3D-based process that then outputs the 2D information, but rather than having it the other way around. And then the level of detail as you go through different phases of the project. You know, blue sky for us was our sort of conceptual phase where we're just sketching. It's just a massing. And then all the way down to operations where you've got to have the bolts and the washers and all of the information that the maintenance crew is going to need to be able to verify and maintain the facility. So I want to walk you how are we doing on time? Is it? Yeah? All right. So one of the exciting things, and I wanted to share with you, was building a castle. You know, who would not want to build a castle? So I got an opportunity to do that. And this project for me holds, you know, it's near and dear to my heart because it was the project that really changed the organization. And I'll talk a little bit about that. But you know, I'll give you an overview of the project, how we use BIM, some of the advantages that were leveraged for, you know, for using BIM on the project, and then some construction processes that we developed. It was the biggest, so Disney, whenever it does a park, it's called the Castle Park. So there's 6 of them. And this was going to be and is the largest castle in the history of Disney. And so these are the 6 parks, and those are the 6 castles, and then Shanghai being the largest one. And it's actually the first one that was inhabitable. There's 4 levels at the base that the guests can actually go into. There was a gallery, a shop, and this is unique and special for a Disney castle. And so the project started out in 2D and in watercolors and, you know, in a typical sort of 2D centric way. And there was a lot of resistance to change. The organization had dabbled years before I had arrived with Revit. They didn't have a good experience. So I insisted that we try to use a tool that's different than just a legacy process like AutoCAD. And we went rogue, me and this young architect, and we kind of did a parallel process behind the scenes. Got a little bit in trouble for it, but I think it paid off because when we got the creative director of the project to stop going through the AutoCAD DWGs just to make sure that all of the information that he was envisioning was correct, and now he can visualize it in an authoring platform like Revit in 3D, it completely changed his perspective on the way he was working. And so once you get the creative guy at Disney to support you, then, you know, all the decisions from there are quite easy. So again, this notion of the integrated BIM model, the BIM coordinator is actually a role, a person that manages the integration of all these disciplines into one platform. And so here we were using Navisworks. And so as you could see, all the disciplines on the left coming together on the right into this integrated platform. And one of the things that we then started doing was leveraging the power of BIM. This castle was filled with ornamentation and componentry, which is very typical of a Disney project. And so we started developing a library of components, intelligent components that could then be attached to the project. That gave us the ability then to kind of treat the castle as a kit of parts, right? And so now we could track all these components. We can track who's building what, when are they going to be built, when are they going to be delivered. Communication, the collaboration between different teams was also important. We had a creative design team in Los Angeles, a delivery team in Shanghai, had to figure out the information exchange process between us and them and how we were going to do this effectively. And then some of the advantages of using this process on the project was, parametric modeling. If you were just drawing this in 2D and you had to make a change, like we had to do in the atrium, way into design, that could be done quite quickly in a parametric model that would then automatically update that information. And so that saved us a tremendous amount of design time and design breakage, if you will. As well as taking, some of these ideas that some of our artists were developing, because these were artists. I mean, these are people that knew how to do glass stained windows, and they've been doing it for their whole life. And so the guy that was working on this was a matured architect, designer, artist, had never used a computer in his life, was basically drawing all of the windows by hand for the project. And so we got together with him and we started capturing the rules that he was using to develop the design. And then we're able to show him, look, you have designed the rules of that window, and now we can spit out thousands and thousands of iterations. And he thought it was like a kid in a candy store. I mean, this was like the most amazing thing he had ever seen. And then attributing the model for the regulatory process so that we could then be able to determine the different materials and the fireproofing for the project. As you guys know, the fireworks are launched right above the castle. It was a big concern. The Chinese regulatory agencies didn't quite understand how did this work, and so it was a good way to communicate this information, as well as traffic control and flow. We started partnering with a research group in Stanford where we began to look at guest flow parking and crowd simulation in the castle, because it was going to be the first castle to be inhabited. From this, we were able to analyze more effectively the demand for the space and certain pinch points that we discovered early on that we were able to change. One of the unique things about Disney projects is that our facilities and operations people are actually part of the design process. So as we're designing and developing the project, they're giving us input, and they can very quickly tell us, how are we going to get a JLG lift so that I can change that light at the top of the atrium? Oh, I don't know, let's find out. So we bring in a JLG lift into the model and we start, and so it's a whole new way of communicating and working with people that are not necessarily in the model all the time, but need to understand what's going on. And then the immersive aspect of what Disney does is very important. So a lot of virtual reality, a lot of visualization, immersion. Here at the bottom left we've got one of our chefs who is going to be in charge of the kitchen. And so very quickly he was able to determine, if the layout was going to work for him. And so he actually, and we did this a number of times where, he would come in and kind of give us, guidance in terms of what was working and what wasn't. And here's a final rendering of the project, the full coordinated model with all 142 disciplines that then led us into construction. And so tying all of that information into the schedule. So our construction schedule is now linked to that model. And we were using the 4D, and the platform here is called Synchro, really to design with. Disney projects are really not so much about the level of detail, but about the sequence of the work. And so using this tool as an orchestration of how the work was going to happen was really effective and really useful for us to be able to communicate with the contractor and with our own project management team. And so here you have, some of those outputs as we began to coordinate and sequence the job, incorporating all of the temporary works, the scaffolding, when each piece was coming in, when was it going to be painted, etc. Used a lot of virtual mock-up processes where we took components from the model that were used to work out the interfaces of these details and how they were going to come together, and then teach the craftsmen on how to do that. This has never been done before in China. And so taking, the digital to the physical in a very direct way. And then 3D scanning, constantly doing as-built verification, making sure that everything was where it was supposed to be. And then some of the images of the construction. This is the basement footers of the castle. And I also wanted to share this, so there's the castle, very traditional, very picturesque. And then there's Tomorrowland. So the castle is the centerpiece of Fantasyland, where all the princesses and all the, the fantasy characters live. Well, Tomorrowland is about the future. And the future looks like this. And this is how we began to think about a whole integrated creative workflow for this team. We wanted to do something new, something unique that had never been done at Disney. And so we created a BIM process for the creative team, not just for the construction team. And so this idea of the core concept and all the different stakeholders that needed to integrate with that model early on was done. And then as we moved through each of the phases of the project, that diagram changed, right? Now you've got new stakeholders, you've got different people inputting. So very intense creative process, a lot of renderings, a lot of imagery, a lot of studies. We worked with Grimshaw Architects who designed the canopy for Tomorrowland. So this was a ETFE covered space frame canopy that sort of covered the concourse for Tomorrowland. And some early sketches in Rhino to kind of visualize the organization of the project, more sketches, iterating through a whole series of forms for the canopy, and then landing on this as our final design. And the orange there is actually the track of the roller coaster. So this is a roller coaster that launched out of the building, went under the canopy, and then came back into the building, into the gravity box. A lot of visualization, immersion. Here's the creative team sitting on one of the concourses looking out imagining what it was going to be like on a Sunday afternoon at Disney in Shanghai, and some of the final renderings for the concept. And then going straight into production. How do we begin to analyze these models for drainage, for maintenance, for the details that actually needed to work. Maintenance and accessibility was also important, so a lot of analysis with the operations team to see how we could reach certain points on the canopy, and then detailing out the gutters. The gutters were a major component of the design, very complex, very important. And then going straight to fabrication from the design model. And some of the images of the construction team and renderings of the interior. And then the tools were also used very effectively in terms of analyzing the eye to visual position and the speed of the vehicle. These were cycles, so you weren't sitting on a car, you were actually riding a Tron cycle that then launched you, so you're literally floating on top of this Tron cycle as you race through the facility. And so that leads us to Mortensen. This is the last chapter of my presentation. I called it Innovation with a Purpose because so all of this stuff that you've seen up to now has been really design focused, creative focused. And for me, it's been really exciting to have been in this role, this VDC role, early on in my career as an architect, then working for the owner and really understanding what that means from an owner's perspective. And so I figured in order to complete the circle, what would that be from a contractor's perspective? So now as the director of VDC here at Mortensen, it's really about the technology and how do we leverage technology for operational efficiencies, operational excellence, bringing greater value to the customer, and really increasing our productivity and our efficiency. So as a builder, the demands are different, and the challenges and the risk factors are different. And so I'll walk you through a project that was completed just recently, the U.S. Bank Stadium, which is where the Vikings, Minnesota Vikings play. But again, using the tools that we've talked about before, but now using them directly as a contractor and looking at how we can integrate the planning of the project more visually and tying the schedules and all of the construction activities as effectively as possible. And so you've got all the components here coming together, the cranes, the locations, all of the madness, if you will, of the construction site can be critically analyzed and organized in an effective way so that we can actually simulate the building of the project. And then tying that to the superintendent activities. So these things are not separate. The superintendent isn't doing something over there and that the VDC guys are doing over here. Those things are actually informing each other. And so what you see here is our superintendent on the right, Dave Mansell, very experienced, probably one of the most famous, infamous Mortensen soups. Great planner, executor, driver of resolution, but a big believer in VDC. And so what you're seeing here is one of these huddle sessions where he's bringing in all the trades, and basically they're planning according to that visual that you saw. They begin to sequence the work that's going to be done on a day-to-day basis. Lots of tech, but one team, one plan. That's always the the objective is how to bring all of these stakeholders and these processes into one workflow, so that we can drive better informed decisions, visualize the work, simulate all the high-risk areas, and bring a higher level of resolution and integration into the process. So for me, having joined Mortensen after all of my experience before, it was a natural fit. These guys have been doing VDC since the day of the Disney concert hall. Mortensen Construction was actually the contractor that built the Disney concert hall. And what was interesting is that as we were asking the same questions as an architect in the beginning in terms of new tools and new processes, from a design standpoint, Mortensen was doing the same thing as a contractor. And the convergence of those two ideas came together in the concert hall. And these two groups basically paralleled each other and became the leaders in the industry in terms of virtual design and construction. So for me, it's been really great to almost come full circle to join Mortensen and bringing all of these ideas together, so that we can begin to think about, what the future is going to hold. And so I want to share this video with you guys to kind of, that's Dave Manzel.
Where do you start? You have to start with a plan.
We hear that?
More time planning, which equates to less time building. We utilize the most advanced tools in the industry, implement lean planning strategies, leverage our sports expertise, and hire the best people.
Mortensen, with the technology they have and the way that they're able to show the job as it's going, makes it easier for every sub. You have a plan, and it's a pretty set plan. It makes everybody's job just much easier. The job gets done in time, people are safe. With the planning so far in advance, a year in advance, we're able to plan for overhead, equipment, and everything else based on using that technology.
Created by adding the element of time to a 3D model, the 4D model allows us to simulate hundreds of solutions and optimize the plan to create the best plan. It helps us visually communicate our plan to our trade partners and better collaborate and execute that plan.
The amount of technology that was used on this project, down to the day on every task, is quite the process and done very well. And having the up-to-date drawings at everybody's fingertips was very important, and it was very easy with the technology that was used, from the submittal exchange even to the punch list. Everything was digitalized and easy to pass along. With all the different trades, it could be very easy to get documents lost. They did a very good job with all the technology that was available to maximize that process.
Without 4D technology, construction would have taken a lot longer. Costs would have been accelerated. Mortensen had committed to using these personnel who were familiar with this technology, and we ended up having the building before we even anticipated getting it.
Virtual reality technology gives us and our customers the ability to visualize completed spaces before any construction has begun. This is a critical tool to make informed decisions while saving time and money and creating the best possible solution.
In addition, lean construction and quality prefabrication materials advance the schedule more so than traditional building practices. Our ability to identify opportunities to prefabricate materials and produce project components off-site absolutely deliver this project faster and with the high quality we require.
These tools, in conjunction with a comprehensive plan, are the reasons we were able to build the U.S. Bank Stadium in a way that delivered the best value for taxpayers and the Vikings, while creating an iconic building resulting in early and under budget completion.
So thank you. Any questions? Yeah, questions? Please, questions.
Go ahead.
I wanted to say thank you. It's amazing to watch, like we're talking on the side, the projects that you're involved with. watching the Morphosis building go up in San Francisco, and that you had a hand in that, and watching some of the other projects. So it's just amazing to track that. And you and I were talking earlier, just maybe both lamenting that we're not working as architects right now, but I think you talked about, or you might explain all the places that you've lived. You showed us the projects that you've worked on and the types of things that you're involved with. And I think it's it's our education as architects that then has allowed you to move into different realms and different possibilities. So it's been a designer, a technologist, leadership roles, and now rethinking construction. And I think that all grows out of the way that you were educated, the way that you think about these things, what you do as an architect. So I think that's a really amazing thing for these guys to see that and understand that. So I want to thank you for that. It's great having you here.
Well, my pleasure.
You have a question?
I do. In terms of the virtual reality, a lot of it was about the experience, right? Being able to experience it firsthand before being in there. Is there any technology where you can simultaneously work within virtual reality? So if you're working with the chef, right, and he says, this aisleway won't be big enough, we just push it back right while you're working within virtual reality? Because I think in the same thing too with some of the Gehry projects, right, where you're forming it in a 3D model, then you have to come back through with the laser. That might be beneficial just to be able to build it out within virtual reality. So I was wondering if there's any, technologies where you could do it simultaneously.
Yes. In fact, so one of the things that Mortensen does is it has to build a new line of business every year, at least one new line of business. Last year, we formed a virtual reality group called Virtual Insights. And it's a group of guys, technologists, that were actually VDC guys, but were really passionate about visualization and virtual reality. And one of the things that we're developing is precisely that, is the ability to collaborate with many people in one space, and then also have the ability to move things in that environment. We're starting to see more of that in some of the one-click VR solutions that are out there. One in particular is Fuser. I don't know if you guys have heard of Fuser. Look at that. I think that is compelling. And then all the BIM tools now are starting to have those capabilities. I think Revit has a VR component to it as well. So VR is becoming ubiquitous, and it's almost becoming a standard in terms of how it's going to be deployed in the industry. So I'm very excited about it. I'm also very excited about augmented reality, which is really even more powerful. I didn't show this, but we're actually using it with some of our tradespeople for something as simple as the blocking location when between studs. So that the J boxes can be located in the right position, and so taking the digital model, overlaying that onto the physical space with some glasses, the guys are very easily can go and just locate these things. They don't have to sit there and look at the drawings, measure, and then come back. It's all seamless in real time.
I actually have about 1,000 questions, but I'll just ask one. So I'm really interested in how, in your work, and particularly with Mortensen, they deal with the larger dilemma of tolerance. So at least within my own digital work, that's always something that's pressing within what I'm designing versus what I'm making. And obviously, the digital tools that I'm using can't necessarily achieve a 0.0001 or greater level of tolerance, but at the same time, if you have a material that's inherently organic or responds to freeze thaw and all these things you're building in the Twin Cities, and you have steel out there, how do you deal with that if the model is simulated and augmented and spec'd and even and built directly from a file?
So, very good question. So I think what you're asking is how do we simulate the physical impact that the environment
just the
would-
tolerance needed for things to fit,
Yeah, and to move.
and to give the trades in the field you
Yeah.
know, some level of error, because error happens.
Yeah. So in the shop drawing process, as we take the design intent model from the architect, which we typically want to rely upon, and we work very closely with our design partners to be able to do that, we take that information and then we start developing the project to a higher level of detail. So through that process, our steel fabricators will come in and we will start capturing that data in the model that then produces the tickets, if you will, for all the steel connections.
So you feed their shop drawing data back into the model to update the master
Correct. So, and it's an interesting process, and it's one that contractually we haven't completely figured out, because it's really one model, right? It's one design, it's one building. But you've got the designer's model, and then you've got the trades model, and typically these groups want to keep things separate, but we as the general contractor need to have that integration. And so we really make sure that that right of reliance is flowing down all the way through to the trades, so that we're not doing rework or redrawing the project, which I think is one of the biggest challenges in our industry. The other challenge is, and we were talking earlier, is document readiness. What do I mean by that? It's, the quality of design, given the speed that things are moving at today, architects just don't have enough time or resources to get to that level of detail. And so there's a gap there that we need to work on. So being able to support our design teams with more of that constructability early on, I think is really important.
Have any other questions? All right.
Oh, okay. Your lecture actually pertains really nicely to some things that we've been discussing in studio lately, in terms of kind of transitioning from working more with paper and with like physical models into now using technology and using software to start the modeling process. So I guess as a designer for you, are there any cues as to when it's time to transition in a design from those physical practices into digital ones? And once you're using digital modeling, do you find that it's easy to kind of jump back to physical hand modeling when you need to? Could you just speak about like the interface of the two?
That's a really great question. That moment of transition from the 2D to the 3D, it's really more about the intention that you have as a designer and the confidence that you feel, I've got the form or the idea really figured out. That's when I think you can make that transition into a 3D model, because now you're going to start working on more precise definition of that design. So it's really up to you as a designer when that moment is. I don't think that there's a hard and true moment. I've seen designers that go straight into the 3D model and are actually sketching in that process. I was like that. It was really hard working with other people in competitions, because you kind of got ahead of the crowd. You'd get to the form really quick, and everybody else was like, all right, well that's the solution. So there's advantages and disadvantages to that, but I think it's really up to you in terms of what your tendencies are and what you want to be able to achieve. Once you get into the model, the whole world starts to open up. You start to see more. You start to make, visualize things that you didn't quite see before, that you can go back to the physical model and test out. I think it's really important to always come out of the computer and test things out physically. I think that there's a certain tangibleness to working with your hand and understanding what you're building and the tactility of that process that the computer doesn't give us yet. So it's really important to think about these things as integrated, not separate. You're welcome.
Any other questions? Well, thank you very much. It was fantastic.
Thank you.
I have so much work to do. Do you know how much work I have to do?
Thank you.
I hope I didn't ask the question. Is in my studio. I was like, hoping.